All right, so people get scared all the time whenever they see algebra. They get scared about it. The reality of it is we're actually a lot more familiar with algebra than we even realize. We've actually used it a lot already, and it's just a matter of now making you aware of really how simple the concept is. All right, so let's take a very simple algebraic equation and take a look at what it actually looks like. So let's say, for example, we had this here. We had 7, and we are going to add in, well, we don't know what we're adding in yet. We're going to add in some number, and then that is going to equal 10. So the reality of it is we actually have an algebraic equation here. Because all an algebraic equation is whenever we're trying to solve for an unknown number. Traditionally, we have equations where we add things up and we want to figure out what they're equal to. In an algebraic equation, you already know what it's equal to, but what we're trying to do is find out what the unknown number is. So if we take a look at this, we could actually rewrite this using something that we use in algebra known as a variable. And all a variable is a letter that is being used instead of the question mark. Okay, so if we rewrote this, it would be 7 plus n, because we're going to choose the letter n to represent this unknown number, equals 10. And then obviously, because we're super intelligent, we can tell that that number is clearly 3. But this is algebra in its most basic form. And this here is known as a variable. And all a variable is a letter used to represent some unknown number. That's it. All right, let's take a look at the difference between an algebraic expression and an algebraic statement, or an algebraic equation. Okay, before we get on to the algebraic expression versus an algebraic statement, I wanted to show a couple little things that are going to be introduced to you because you're now doing algebra and you're doing math at a higher level. These are common things that mathematicians do when they're multiplying and dividing in algebra. Okay, so we know already that n just simply represents an unknown number. That means an unknown number. And from our previous example, we knew that it meant, so when we went 7 plus n equals 10, this just means that we haven't yet figured out what that number is. That's all that means. But we can also multiply by unknown numbers. And when we're doing algebra, earlier on, we would take things like we'd say 7 times 3 equals 21. Well, because now that it's an unknown number, let's say we didn't know what the 3 was, we would simply put 7 times n equals 21. Now, this is correct, but in algebra, the way we write this is simply 7n. And we do that because a lot of in algebra, especially, they use the symbol x. And a lot of times it causes confusion because people think they're supposed to multiply, and in actuality what it is it's a variable. So instead of putting the little times in there, this simply here means whenever you see a number butted up against the letter, that simply means 7 times the number. That's all it means. But it'll only be written as 7n. Okay? I'll show you another example. Okay, another example of this is in division. So we would know that we could say something like 10 divided by a number equals 2. Okay, so rather than write it like this, we can change this out and we can simply put in a number like n. So 10 times some number is going to equal 2. Alright, now rather than write it like this with the division sign, we write it almost like a fraction now. This is a more common practice, is when we write it, if we remember for fractions, that line in between the numerator and denominator means divide. So we would say rather than 10 divided by a number in the traditional way, we write it as 10 over n equals 2. So we could say that 10 divided by a number that we don't know yet is going to equal 2. And that's the way we write it. Let's take a little bit of a look between what the difference between an equation and an expression is when coming to algebra. Because you'll hear both. It's an algebraic equation or an algebraic expression. The big difference between the two of them is that one of them has an equal sign. And if you think of which one has equal sign, we'll look for the root. Equal. Okay, equation. Okay, that's how we can remember. Now let's take a look at an example to kind of explain how this works. Let's take for example a hot dog sale. You wanted to sell hot dogs to raise some money, and you decided that you were going to charge $2 per hot dog, and we could write an algebraic equation that says that when we sell $2 or each hot dog for $2, and we're going to we don't know how many we're going to sell yet, so we'd say $2 times the number of hot dogs sold, so we're going to say n in that case. It's going to equal the total money earned. Okay, so we know that, we don't know how many hot dogs we're going to sell, but at the end, we can say that we count up the number of hot dogs that we sold, we multiply that by 2, because that's how much we're charging, and that's going to be the total money that we take in. All right, now the way we would write this as an algebraic equation would be like this. We'd say 2n equals total money earned. All right, well, let's say, for example, n is actually equal to, say, 50. Say you sold 50 hot dogs. Well, what you're going to do is you're actually going to plug in the number 50 for n. So now the equation actually turns into 2 times 50 equals, and what is it going to equal? It's going to equal the total money earned. So how much is the total money earned? In this case, it's $100. This is an algebraic equation, okay? Because what we've done is we started off with our algebraic equation here, 2n equals total money earned, and what we did is we plugged in a number for n, and we said n is actually equal to something. Now, what we did at the beginning where we said 2n, this here is the algebraic expression. We know that that is going to give us the result. That's how we're going to figure out the total money earned, is by taking $2 and multiplying it by the number of hot dogs. This is an expression on its own because it's 2 times the number. But the second that you add in an equal sign, like you did over here, and you make it equal to something, then now it becomes an equation. Okay, I've given you some examples here so we can start to see the difference, what an equation versus an expression looks like. So first thing we do is we just look at it and say, okay, well, it's n plus 4. And since there's no equal sign there, we automatically know that this is an expression. Okay? And we look at the next one here, we say 2n plus 1, and clearly there's an equals, and there is something that it's equal to. It's equal to 7. This is an equation. Okay, again, a number divided by 6, but it's nothing to equal to. This is an expression. 4 times a number, that's an expression because it's not equal to anything. 2 times a number equals 12. That is an equation. Okay, a number divided by 4 equals 6. That is an equation. And finally, 2 minus n, there's no equal sign. This is an expression. All right, the last thing I want to cover is a few of the important vocabulary words to identify different parts of an algebraic expression and or an algebraic equation. What we've got here is we've got an expression because it's not equal to anything yet. So it's 2 times a number plus 7. And each one of these symbols in this expression has a specific name. The one that we're already familiar with is this one here, and this is what is known as a variable. And we know that a variable just simply represents an unknown number. But what we also have in this algebraic expression is what we refer to as a constant term. And you'll get to see why this is important later on once we start doing our input and output tables. But for now, I want you to understand that it is a standalone number and it is a constant term because it is constant. It never actually changes. Whereas n can change because we can put any number in for n. We just don't know what it is yet. The last number that we're going to take a look at is this 2 right here. And because this 2 is codependent on n, because it's multiplied by n, this is known as the numerical coefficient. And that just simply means that it is directly related to n, because if we change what n is, then the result of 2 times that number is going to change every single time. So it is directly related to it. Whereas this number here is going to stay the same no matter what. All right, so let's move on in our next video, and we're going to take a look at input-output tables, and we're going to get an idea as to why constant term is important and why how we can use all of this this information that we've already learned.